This video explores the line equation y equals mx plus b. So let's write this out. Y equals mx plus b. And this is the slope-intercept form, and it's called that because the parameters specify the slope and the y-intercept, where this line crosses the y-axis. So let's plot a few things and take a look at this. The hope is this will help build your intuition about these parameters and how the line graphically behaves. So we have y equals mx plus b. Let's first just assign m equal to a real value number, so 1, and we'll set b equal to 0. I'm going to plot a coordinate pair along with this. I'm going to plot the point 0, comma b, and that is what is meant by the y-intercept, and it's a parameter. The parameter b defines where along the y-axis this line will intercept it. So we'll keep an eye on this blue point as we change the value of b. Let's do that first. So I'm going to create a slider here for b and just start dragging it. So as I increase b, you can see that blue dot showing that coordinate pair 0, comma b shifts up, and as I drag it down to negative values, it moves down as well. Okay? So that's the idea behind the y-intercept. Now, I'll set b back to 0, and let's look at m. If I create a slider for m and start increasing it, we can see what is happening with the slope. It's becoming more and more vertical. Now if I drag it towards 0, it becomes horizontal, and as I go into negative numbers, it also becomes more vertical, except to the right, positive x values, it's sloping, moving down instead of up. So let's plot one more coordinate pair here. Let's plot the point 1, comma m. Sorry, 1, comma b plus m. And why that point? Let's have a look at how it changes. So it's on the line, first of all, and we can see that the line always passes through it. Now let's see what happens if we change b away from 0. And we can see it's still passing through it. So with this form, in this setup, we can see that the line passes through the point 0, comma b, and the point 1, comma b plus m. Okay, let's look at one other version of this. Create a new tab here. So y, again, equals mx plus b. This is the slope-intercept form of the line. Let's create a graph for that. And zoom in a little. This time we're going to write m as a fraction, s over r. And again, set b equal to 0. So s and r, let's give them some values. So we'll say s equals 1. Create a slider for that. And say r equals 1. Create a slider for that. Let's put some points down again. We'll use the same one as before, 0, comma b. And then let's use the point. So s and r here mean rise over run. This defines where the next point on the curve will be from a given point. So from any point, if we go up s units and to the right r units, if r is positive, we'll find the next point on the graph, on the line. So if we're at 0, comma b, then the run, this bottom one, is r, so we know we'll be at r, comma b plus s. Let's check that. So if we were at 0, comma b, now the rise is s, so we know we'll be at the point b plus s, and the run is r, so 0 plus r is r. It's at that point. Okay, let's start varying all three of these parameters now. We have b, this y-intercept, s, the rise, and r, the run. So we'll start with b. As we shift this up and down, we can see those 2 points stay on the line. Step back to 0. Now let's vary s. We're going to set these to discrete sliders. So as the rise changes, the slope goes is higher, and the line passes through both points again, still. Okay, now let's increase the run. So instead of going over 1 and down, it'll be over 2 and down. And if we go to negative numbers, we can see this works. Now something interesting happens when r is 0, which is a divide by 0. Alright, that concludes this video.